So can you talk about the different areas or categories of artificial intelligence?
Now, there are lots of different fields that AI works in, but if I were to, on a very, very high level, group some of the major areas where artificial intelligence is applied, I'd like to start off with natural language. Because natural language is, I'd say, the most complex data for machine learning to work with. If you see all sorts of data, whether that be a sequenced genome, whether that be audio, whether that be images, there's some sort of discernible pattern. There's some sort of, yes, this is what a car sounds like, or yes, this is what human voice sounds like. But natural language is fundamentally a very human task. It's a very human data source. We as humans invented it for humans to understand. If I were to, for example, give you a book title, there's actually a very, very famous book, and the title of the book is "There Are Two Mistakes in the title of this book." Now, there's actually only one mistake. There are two thes. The human brain doesn't realize that. What's the second mistake? That there was only one mistake. So this is the sort of natural language complexity that's involved here. Humans don't view natural language literally. We view it conceptually. If I were to write a 3 instead of an E, you would understand it because we don't mean the 3 in a literal sense. We mean that in a symbolic sense to represent the concept of E. And you can contextualize that 3 to figure out that, yeah, it means an E and not an actual 3. These are things that computers aren't capable of. So natural language is the #1 sort of field that I'm most interested in when it comes to machine learning. Second, I'd say the most popular would be visual data understanding, computer vision, because it enables us to do so many things. I mean, as humans, our primary sense is vision. In fact, a vast majority of your brain's processing power at any given moment goes to understanding what it is that you're seeing, whether it be a person's face, or whether it be a computer, or some text, or anything of that sort. And third, I would say audio-based data. So text-to-speech, speech-to-text, these are very, very complex. And the reason it's complex is because it kind of combines a lot of challenges into one. First of all, you've got to support many languages. You can't just support English and call it a day. You've got to support the other languages. You've got to support other demographics. And another challenge is that even within languages, there are absolutely infinite number of ways that any human could represent a language. Everyone's going to have a different accent. Everyone's going to have a different way of pronouncing certain words. There's no standardized way that every human will pronounce ice cube exactly like ice cube. That doesn't exist. And if you take a look at another challenge, it's that audio data is fundamentally very, very difficult to work with. Because the thing is, audio data exists in the natural world. What is audio? It's vibrations of air molecules. And vibrations of air molecules are fast. And audio is recorded at over, say, 44 kilohertz. That's a lot of data. 44,000 data points every single second. There are usually only 44,000 data points in an individual low-resolution image. So, of course, there are lots of challenges to work around when it comes to audio. But companies like IBM, Google, Microsoft have actually worked around these challenges, and they're working towards creating different services to make it easier for developers. So again, on a very, very high level, there's natural language understanding, there's computer vision, there's audio data, and of course there's the traditional set of tabular data understanding, which is essentially structured data understanding.